So we're going to be in section 5.2. We're continuing with this, talking about negative exponent rules. And in our previous video, I introduced the rule to you. And what it said is that if you have some base to a negative power, the way you make it become positive is to put it underneath 1. In other words, think about that as a fraction. Move that base and its exponent, negative exponent, to the opposite place. And when you move it, it's going to change that exponent from a positive to a negative. And so we're going to pick up here looking at each of these examples. And you'll notice that our directions say to evaluate. So what that means is that we need to actually tell what that number is. And so based on that exponent rule, again, I'll rewrite it for you here. So based off of that, if we were to take both of these terms and write them as positive exponents, because we don't know enough about negative exponents to say 4 to the negative first minus 2 to the negative first is whatever. However, we know plenty about positive exponents, where if we can make both of these be positive exponents, then we should be able to rewrite these and figure out whatever this answer should be. So to take 4 to the negative first, again, think about it as a fraction, being over 1. To make it be a positive exponent, we need to take the 4 to the negative first and send it to the bottom, which means it's going to be 1 over 4 to the first, or just 1 over 4. And then if we do the same thing with 2 to the negative first, again, think about that as being over 1. Take the 2 and the negative exponent, move it to the bottom. So have a 1 that's understood on top, and now 2 to the first, or just 2 on the bottom. And now to be able to subtract those, we have to find a common denominator. And so we're going to multiply this by 2 over 2. We've talked a good bit about how to get a common denominator and how to add and subtract fractions. So that should be something you can do at this point. So this is really 1/4 minus 2/4. And when you do that subtraction, 1 minus 2 is negative 1 over 4. So there's our solution. Again, the key here is writing this with a positive exponent. So if you look at the next one, and we again write this one with a positive exponent, we're going to take that base and its negative power, which is on the bottom of the fraction, and now move it to the top. And when you move it to the top, it becomes 4 to the positive third. And it's technically over 1, but again, that 1 is understood, and so there's no need for it. And so we have 4 to the third, which is 64. And that's all you do. Again, the key here is moving your negative exponent from the top to the bottom, or from the bottom to the top, just moving it to the opposite place. So if you look at the next one, my question typically is, okay, how do we think we're going to get these to be positive exponents? And I hear people say flip it. And in this case, that is true. I hesitate to use that word flip because in the previous problem, this one down here, we are not just flipping because we're not moving that 1 to the bottom. And so I stay away from that term, flip it. But in this case, we literally are going to flip it because we're going to take this 3 to the negative third and we're going to send it to the bottom. And we're going to take this 9 to the negative first and we're going to send it to the top. And so we did literally just flip that. And so that 9 to the first is on top and 3 to the third is on the bottom. 9 to the first is 9. 3 cubed is 27. And then that does simplify to 1/3. And so there's our final answer. Now, look on the last one. Notice here what has the negative exponent. So this h to the negative fifth and this m to the negative second are the only ones that are only bases that have negative exponents. The 4 hasn't understood 1, the k hasn't understood 1, both those being positive. So we're going to move this h to the negative fifth to the bottom and m to the second to the top. And again, when we move these things, their exponents are changing signs. And so on the top, we're going to have the 4 that's already there, the m to the second, or m squared in this case, that now has a positive 2 for the exponent. And then on the bottom, we have the k that was already down there. And we have the h to the negative fifth, which is going to be an h to a positive fifth when we move it. And then there's nothing else we can do with that. We have all of our positive exponents. Everything is simplified. That is our final answer. If you have any questions about how to use that negative exponent rule, please let me know. Shoot me an email and I'll try to help you. So our last three rules here, two of these deal with negative exponents. And so our book refers to these as special rules for negative exponents. The first one, this one, says that if you have a fraction raised to a negative power, you can flip that fraction and that exponent is going to become positive. And we can talk about why that works the way it does. Basically, you just need to know that if you were to flip that whole fraction, that power is going to become positive. Okay, now, with that being said, a couple videos ago, I gave you 4 steps for simplifying exponential expressions. In those 4 steps, if you follow those 4 steps, you're not actually going to need this rule. Now, when you get into college algebra, there's going to be some times when you'll need that rule. There will be some instances where you may need to use this rule because it does save you some time. But for what we're going to do in this class, that rule is not going to be all that necessary. The next rule is what we just saw. We just saw it on this problem. And it says that if you have this base raised to a negative power on top and bottom, so negative exponent on top and bottom, you can literally flip that whole fraction. Take the one that's on bottom to the top and the one that's on top to the bottom, and those exponents become positive. And so again, you've seen that already. And so when we talk about negative exponents, our biggest thing is we need to move the base and its exponent to the top if it's on the bottom, or to the bottom if it's on the top. And when we do, the sign of the exponent changes. Okay? And then our last rule is what we call the quotient rule. And so the quotient rule is the opposite of the product rule. Product rule said, if you remember back a few videos ago, it said if you have this, said if you are multiplying and you have the same base, you keep the base and add exponents. Well, this one now says if you're dividing and you have the same base, you keep the base and subtract exponents. Okay? So when we talk about the quotient rule, we are subtracting exponents. Now, one thing to be aware of, it is always the top exponent minus the bottom exponent. So there could be some situations with signs we're going to talk about in a second that could be sort of an issue there. So you need to be really careful and understand what is this talking about. So let's look at a few examples. On the first one, we're going to use the quotient rule. And I'm going to use it a little bit differently than the way it's written. So the way it's written, it says that you're going to keep your base and you're going to subtract exponents. So 8 minus 13. But the issue that you run into is that 8 minus 13 is a negative 5. And then we need to make that be a positive. And so to make that be a positive exponent, we make it 1 over m to the 5th. Now, that works fine. But a couple of issues that you might run into. Sometimes people want to say 13 minus 8 and put 5. Well, m to the 5th is different than m to the negative 5th. If you do the subtraction right and you end up with a negative exponent, sometimes dealing with that negative exponent is also difficult for some people. And so there are some potential issues that you could run into. So here's what I would suggest to you. When I look at the quotient rule, I approach it a little bit differently. I think about what's actually happening. So let me rewrite this up here so that if we take m to the 8th, it's literally m times m 8 times. And then on the bottom, m to the 13th is m times m times m 13 times. Now, I'm not going to ask you to write out every one of these m's every single time. However, I do think it's a good idea to think about what is happening when you do this division. Well, if you look at what we have, m divided by m is just 1, right? Just like 2 divided by 2 is 1 and 3 divided by 3 is 1, m divided by m is 1. And so 1 times everything else is just everything else. And so what happens is this m on top and this m on the bottom, they cancel each other out. Well, then there's another m on top and m on bottom. And there's another one and another set. And so what happens is you end up having a bunch of m's that cancel out. And so when you get finished canceling all of those out, what's left? Well, on the top, there's not any m's. That's an understood 1. And on the bottom, you have 1, 2, 3, 4, 5 m's being multiplied together. That's m to the 5th. The same answer that we had here, but if you just think about, okay, what cancels out, it's a lot easier. Because what I'm going to do is I'm not going to write out all these m's every time. When I do this, I'm going to look at the original problem here, and I'm going to say, okay, there's 8 m's on top. Those 8 cancel 8 of these 13. It means there's 5 left on the bottom. And then I'm going to write it as what's on top, which is understood 1, over m to the 5th. Again, to get us to that answer. And so it is my opinion that if you'll approach the quotient rule this way, it will be very easy for you and there won't be a lot of mistakes. If you try to write it by subtracting every time, there are potential mistakes that you could run into. And if you do, obviously that's going to be an issue. Okay? So, look at this next one. If we were to take this one and approach it the way the quotient rule says, it says you're going to keep your base of 5 and you're going to subtract exponents. Well, when you subtract, it's negative 6 minus negative 8. Now, you can probably imagine one of the common mistakes I see is people say negative 6 minus 8. Well, that's different than negative 6 minus negative 8. Because if you do this correctly and you get all your negatives in there, that minus a negative becomes positive, and then it's negative 6 plus 8, which is 2, and so you get 5 squared, which we know is 25. Again, no big deal. But here's the way I would approach it. I would start out by making my exponents positive. And so the way we do that, we have just seen, you flip this and make it 5 to the 8th divided by 5 to the 6th. And then we're going to think about, well, what cancels out? Well, there's 6 5s on the bottom. There's 8 of those on top. So those 6 on bottom cancel 6 of the 8. Means there's 2 left. Now, pay attention to where those 2 5s are. They're on top, right? And so on the top, we have 5 squared, which is 25. And so we're able to get our answer. And not very many ways that you would make a mistake if you do it this way. So as we approach the quotient rule, this is going to be the way I suggest you do it. Again, think about what cancels. I think that'll make a lot of sense for you moving forward. Now, look at the next one. We have x cubed divided by y to the 5th. So our quotient rule says if the base is the same, keep the base, subtract exponents. Well, our base isn't the same. And so if you were to think about this, you say, okay, what cancels out? Well, there's not any x's that cancel because there's not x's on top and bottom. There's not any y's that cancel because there's no y's on top and bottom. And so because of that, the quotient rule doesn't apply here. So that's all we're going to say is that the quotient rule does not apply. And we'll say D and A for does not apply. And then on the last one, this uses the rule we said we're not going to use much. I do want to at least show you how it works if you need to use it. So on this one, you're going to flip your fraction, make it 3 over 2. And when you do, it's going to change that exponent to a positive fourth. And so then as we simplify, we have 3 to the fourth. Because remember that exponent goes to top and bottom. And then we have 2 to the fourth. And then we're going to simplify that. So 3 to the fourth, 3 times 3 is 9, times 3 is 27, times 3 is going to be 81. And then 2 to the fourth is 16. And there's our final answer. If this original fraction does not simplify, then the answer won't simplify either. Okay? So we're going to stop there. In our next video, I'll tell you what, let's go ahead and do it. That way we'll finish this section. So we've gone through all 9 exponent rules, right? And as we go through these, I've given you enough information I could give you these and say, okay, go for it. But odds are you're going to kind of look at me like, I don't know what you want me to do. And so this is where those 4 steps that I gave you a couple videos ago really comes in handy, because those 4 steps for simplifying exponential expressions are going to give you a way to start and stop with every problem. For example, let me just back up and show you. There they are. All right, so there's our 4 steps. First thing is that we're going to get rid of the parentheses using those power rules. The next thing is we're going to get rid of the negative exponents. There's 3 of those. We've talked about those today. Then the product rule, which is a rule by itself, and the quotient rule. And you'll notice the 0 exponent rule is not listed because it is kind of separate and it's on its own. Okay? So, as we look at simplifying these, we're going to approach these using those 4 steps. And you can do it a number of ways. This is what I think will be easiest for you. Okay? So, on the first one, we have a power raised to a power. And our first step is get rid of the parentheses. And so we're going to rewrite that as 4 to the negative 10th, because the power to a power says we're going to multiply those exponents. And then we can't have a negative exponent, so we're going to rewrite it as 1 over 4 to the 10th. And then 4 to the 10th is a really big number. We're not going to tell that number. We're going to simply leave it as 1 over 4 to the 10th. So, not terrible. We got rid of the parentheses. We got rid of the negative exponents. The product rule didn't apply here because you didn't have anything being multiplied that had the same base. And the quotient rule doesn't apply because there's nothing being divided that has the same base. Okay, so that's the way we're going to work through each of these. On the next one, we don't have any parentheses, right? This one at the bottom. But we do have negative exponents. And so if we take this x to the negative 4th and write it as a positive exponent, it's 1 over x to the 4th. And we can do the same thing with x to the negative 6, write it as 1 over x to the positive 6th. And then it's being multiplied by this x to the 8th. And I'm going to write it as x to the 8th over 1. And the reason I do that is because I want you to see that it is on top. When you're multiplying these fractions, that x to the 8th is on top. Now, we got rid of the negative exponents. Our next step is to use the product rule. Well, the product rule comes into play here when you're multiplying x to the 4th times x to the 6th. Because we know that when we multiply fractions, we multiply straight across. And so, in this case, we're going to have x to the 8th on top. So 1 times x to the 8th. And then on the bottom, we do have the product rule, that x to the 4th times x to the 6th. Product rule says we're going to keep the base and add exponents. And so 4 plus 6 is 10. And then our quotient rule says that we're going to cancel stuff out, right? So there are 8 x's on top. There's 10 on bottom. These 8 on top cancel 8 of the 10. It means there's 2 left. And so we end up with 1 on top over x squared. That is on the bottom. There is the final answer. Now, I would encourage you to pause the video and try the next 2 on your own. I'm going to quickly run through those, but I would encourage you to pause the video now, and we'll work through it together in a second. Okay, so assuming that you've work these. First thing we're going to do is we're going to take this power of -2 and we're going to give it to everything on the inside of that fraction, or of that parentheses. So this m squared is going to get the negative second power. N is going to get the negative second power. And on the bottom, we're going to leave that m to the negative third and the n. Now, we still have a set of parentheses. This 2 to the negative second, this m squared to the negative second, that's a power to a power. And so we're going to multiply those, and we're going to get m to the negative fourth, n to the negative second. And then on the bottom, we're going to keep the m to the negative third for just a minute, and the n. So now we've gotten rid of the parentheses. And it's very possible you could have skipped this step. If you already knew that m squared to the negative second was going to be m to the negative fourth, you could have skipped that middle step there. Now we need to take our negative exponents and get rid of those. And so this base and power, this base and power, and this base and power all need to get moved to the opposite place. So when we do, on the top, we're going to have m cubed, because this m to the third goes to the top. And then on the bottom, we're going to have m to the fourth. We're going to have n squared. Those were both on top. We moved them to the bottom. And then there's also the n that was on the bottom, the one that was already there. And so now we have positive exponents. Our next step is use the product rule. Again, the product rule does come into play here with those n's. They're being multiplied. They have the same base. We can add their exponents. And so we have m cubed over m to the fourth n cubed. And then the quotient rule says that we're going to cancel stuff out. Well, there's m's on top and m's on bottom. So the 3 m's on the top will cancel 3 of the 4 that are on the bottom. And that's all it can cancel out. So what's left is 1 on top, m n cubed on the bottom. And so there is that final answer. Now, on the next one, we're again going to approach this kind of the same way. We're going to get rid of the parentheses first. So we're going to give the power of 2 to everything in that first fraction. So the 2 gets squared, the y gets squared, and on the bottom, x cubed gets squared. And then in that second fraction, we're going to give that power of -1 to everything. So the 4 gets the negative first power, y gets the negative first power, and x gets the negative first power. Now, we still have this set of parentheses here at the bottom. And I'm actually going, just for the sake of having some space here, I'm actually going to take this and erase it and rewrite it. So this x to the third to the second, that power to a power, we're going to multiply those exponents. So I'm actually going to erase that and make that x to the sixth. That way, I'll give myself a little more space here. So now we need to get rid of the negative exponents. So this 4 to the negative first, y to the negative first, and x to the negative first, they're all going to get moved to the opposite place. I am going to go ahead and square the 2. So 2 squared is 4. And then we have y squared. And on the bottom we have x to the sixth. And then in this other fraction, everything's getting flipped. So the x to the first goes to the top. 4 and y both go to the bottom. And now we know that when we multiply fractions, we multiply straight across. And this is where the product rule would come in. But we really don't have anything to combine. So there's not any x's that are being multiplied or y's being multiplied on top or bottom. And so we can just write all this together. On the top, if you multiply straight across, we have 4y squared x. And then on the bottom, we have this 4, I'm going to put it in the front, x to the 6th, and y. And so then we need to cancel stuff out using the quotient rule. And so the quotient rule allows us to say, well, 4 divided by 4 is 1, it cancels. The 1y on the bottom cancels one of these y's that are on top. And the 1x that's on the top cancels one of the 6 and leaves us with 5 of those on the bottom.